Hello once again, my fellow mathematicians. We're going to be doing more hyperbolic, straight edge, and compass constructions in GeoGebra. And in this video, we're going to take a hyperbolic circle and a point outside that circle. Actually, we'll do the inside one first. So we'll make our circle a little bigger. But we're going to take a point inside, and I'll give them a color so it's easier to figure out which one we're talking about. So we'll take a point inside and these other 2 points that create a hyperbolic circle, and we're going to reflect this point outside the circle. And we're going to do it in the exact same sort of manner that we did reflecting a point inside a circle to the outside when we were working with the regular Euclidean plane. Okay, but we're going to do this with our straight edge and compass, our hyperbolic straight edge and compass. So let's get started with that. Well, how did we do it in the Euclidean, in the flat plane sense? Well, we connected these guys up, and we get a perpendicular line. Oops, something's going wrong. There we go. We get our other point here. And it's a little hard to tell, but there we go. And now we need the line through these. And this line will then give us our tangent points to the circle. And then we just extend those tangent points, and we get the tangent lines, and they will meet the original line that we created. And we'll be all good to go. And I'll do both of the tangent line constructions to show you that they really do both meet again at the same point, and that point is the interesting inverse point, the reflection of this forced green point in our hyperbolic circle. So let's get some tangent lines created. All right. So once again, we need perpendicular line through through a given point. Go intersections there and there. All right, so that does give a tangent line, although rather interestingly, it doesn't intersect this line as one would hope. So there we get the intersection there, and I just learned something there because I did not know that this construction could fail. I wonder what's going on there. Some interesting stuff, I'm sure, and something that I'll be interested to read about in the future. But assuming that these guys do intersect, which is, I guess there's no way that this tangent line could be parallel, but I guess in hyperbolic geometry, you can have a tangent line parallel to an extended diameter. Okay. It could also fail in Euclidean geometry if the point and the center coincided, because then your tangent line would be parallel and they wouldn't intersect. So yeah, this is not unreasonable. Got to make sure our point that we're given is in the right spot so that we do get tangent lines that intersect this extended diameter. But wow, that's nifty. I'd never seen that fail before, even when I did a practice run of this a little while ago. So hyperbolic geometry is just full of surprises. I'm actually glad that sort of, well, I wouldn't say backfired, because it's not like I'm trying to impress everybody here, but I'm glad that happened, because I didn't know that about hyperbolic geometry. Oh, did I? Oh, I goofed and I got rid of the line going through there. Well, I'm going to have to reconstruct that one. Unless... Yeah, we'll just deselect this guy. And then we'll flip it all back. There we go. Alright, fun GeoGebra command saved the day. I selected everything. I switched to the hiding commands with the. I changed everything that was hidden to unhidden and unhidden to hidden, and then I just selected my tangent line and brought him back. I accidentally made him invisible there for a little while. Now you can see, hey, they all intersect at the same point, and this is the point that is sort of the inverse, the reflection of our forest green point in our circle. Okay, so we can clean this up a little bit and create a brand new tool. Now, when I did the Euclidean geometry version of this, I did both of them in the same video, but I'm actually in the next video going to reflect from outside to inside the circle. Same sort of construction, I just wanted to separate it up into two videos, because if you might remember the Euclidean one, I then bounced this point around and showed you that everything gets created, but I think you can tell by now, if you've watched any of the other videos, you know GeoGebra is not going to let me just move points around and have everything be nice and neat. And that's, again, I chalk that up just to the circular arc tool. Other than that, I find GeoGebra is a fine program. So we'll just quickly create our new tool. We'll highlight this guy. So that'll be our output, our inputs. We need the disk. So A is the center, and then B is the point that helped us create the hyperbolic circle. C is the point that we want to reflect, and it's all inside our hyperbolic geometry environment, the disk. And we get out our point here. So this is going to be reflect to outside the circle. And we have, so reflect from inside to out. So there's our brand new tool, and in the next video, as I say, we're going to follow this up and reflect from outside to inside. Okay? So have yourselves a wonderful day in the meantime. I look forward to seeing you guys in the next video.